when you have a sphere, you have the original drip line, which you could get just by doing, mechanically doing that, drawing a circle at the base of the cube. Okay? But then what's going to happen is someone had an interesting question in the morning class about, like, well, what happens if you have an extreme side light angle? You know, that drip line for your new cylinder is getting really skinny. Do you see that? And she said, is that okay? And I said, yeah, it's okay, but notice that the major axis is going to change on that ellipse down there, but the minor does not. You see that? This ellipse becomes a circle, effectively, at that, you know, as that happens. So you get some strange things happening where, like, if I have a line like this, notice that if I have the light coming in at that angle, well, now you know, that's my drip line, essentially. Does that make sense?
If it was a tiny little circle like that, where would... Oh, wait, no, it makes sense now.
Okay. So in any case, when you're looking at this, you realize that I have some Delilahs in the front of the cube, or the front of the sphere, and they connect to here and to here. I use this is my drip line ellipse, my original one. And then here's the resulting ellipse for the shadow. Yeah.
So, I noticed you kind of stopped drawing Delilahs once you got halfway. Do you just...
Oh, we were running out of time, and they were understanding what I was doing, because I was taking this drawing took like 20 minutes. We were spending a lot of time discussing things back and forth, and they were watching me do it step by step. So once I did these 3, did 2 more, and then I did these 3, and after I'd done 8 of them, the class was starting to go, okay, yeah, we get it. Shut up.
So we should draw them all the way.
I would put in as many as you need. Now, here's one thing you may think about. You might consider doing the ones on the back of the ellipse first, because it'll get less messy for you. The ones on the front are easier for you to see, but if you do all of these and then you go to do all the ones going across the back, you're going to have a hard time keeping your lines straight, meaning keeping them not getting confused. Yes?
After you find the
Yes.
location of your sphere, do you need the cube to find the shadow?
Okay, let's talk about this. This is another thing, and I want to go over this, and I'm going to do this part a little bit mechanically, because I want you guys to see it. Okay, now you guys, I'm going to do a little bit of this mechanically because I think it'll help your comprehension of this idea. And this is something I expected to go over anyway, because it's probably, honestly, I think it's probably conceptually the most difficult thing I will present to you all semester, even more so than like aerial views. But with this right here, you guys are all cool up to that point, right? Everybody knows how we're doing that. Okay, now, imagine this. You have to, I'm not going to draw the sphere exactly, but imagine I have a sphere up here. You know, I'm not going to draw it. I don't want to muddle the drawing. And I have a light source. My light source is here. Now, here's the question. Okay, now I'm going to, Yafa, since you asked the question, I'm going to let you be the instigator, or the participant, kind of. Do you see that if I put a radiation point there for that light source, it's a gargantuan light source 3 miles away. You see that? But if I do it here, now it's a not very gargantuan light source, and it's pretty close, to me at least. Okay? Now, if I have a sphere here, where would I want the light to be if I wanted to create no ellipse at all on the shadow? What do you think, yeah? Where would I, like if where I put the radiation point along this line determines the location of the light, where do I want to put the light so that I create just a line for a shadow? Yeah, exactly. If I go like this, if I put my radiation point right there, that's going to result in a shadow. If this is my center point for the sphere, it would create a shadow that was just a line like that, because the light's coming perfectly from the side. Now, this is where I want you guys to follow along, because we explained this before, but I think you guys are kind of more ready for it now. If I wanted the light 45 degrees in front of the sphere, keep your eyes up for this next step. I would extend this line. This is why the cube is still useful. I extend that diagonal. Where it hits that line, the light is now hitting the sphere at a 45-degree angle. Okay? Now, this is important because, watch this. Okay, this, if I go from the center halfway to the outside of the sphere, that's a 30-degree ellipse. If I go half again, that's a 45. So, I'm going to do that. And I'm going to draw this in here. So that's a 45-degree ellipse on the sphere. Now here's what's important about this. That's the plane. Now, I just did the 45 degrees in front. If I did the reverse, if I wanted it 45 degrees behind the thing, I would extend the other diagonal. Now the light source is 45 degrees behind. You see what I mean? Now, notice, I don't have to change the ellipse. I just use the other line as the start of the shadow. Does that make sense to you? So if it's in front, well, I have this little tiny sliver. If it's in back, does that make sense? Now, if you take those distances and you split the angle, I think that's my 5-minute warning. That's how you can kind of guesstimate what angle your ellipse terminator should be at. Let me be very clear about it. Can someone tell me, is it 3 o'clock?
It's 5:55. 2:55.
Oh. I thought someone said, it's 3 o'clock. Good. So where the light, it's like, was it off that whole time? You guys were just, okay. So that red line, I was thinking, man, you guys need to speak up. Okay. So where the radiation point line crosses that side of the square is very helpful in determining the ellipse, because you can guess if it hits near the 45, hits near the center, hits near the other 45, it kind of tells you. Now, some of you guys have situations where it's hitting out here or on the other side. Well, think about it. This is 45. This is directly in front. Then this is 60. This is 75. Now, when you get into a 75-degree ellipse, that's like it's 9/10 the height. It's almost a circle again. You see, I mean, if you're in a 60-degree ellipse, I think a 60-degree ellipse is 7/8. So that's like 87% the height. And so you're seeing, at that point, you're seeing the most, just an absolute sliver of shadow when you get into 60 and 75 degrees. Does that make sense? Now, you guys, so we have 5 more good minutes. What would be the best use of the time? Do you guys have additional, actually, how about additional questions first? Yes?
How do you find the shadow under the sphere? Like the radius to the Delilah that's under the sphere?
The radius to the Delilah that's under the sphere.
Like, how would I find where this is the ground?
Oh,
Is it just an extension of
that's it. What it is it's, let me illustrate that. That's a good question, and I think it's one I can